Everyone. I'll present actually on the trends in ozone and NO2 in the Uintah Basin, looking into what's the influence of oil and gas production and wildfires. To talk about the motivation of this work, we all know that extraction of oil and gas leads to NOx and VOC emissions. It leads to elevated ozone levels that can exceed the national ambient air quality standards. Wintertime ozone has been extensively studied in the Uintah Basin. Mansfield and Lyman had reported last year the decrease in the ozone exceedances over the year. We all know that wildland fires, they produce significant air pollution. It pose a risk to those in proximity and downwind population. More wildfires and air quality deterioration are expected in the future under climate change. And Uintah Basin on the Utah part is currently designated as a non-attainment area for ozone. We all heard in a couple of talks, the National Ambient Air Quality Standards, it was established through the Clean Air Act. I will emphasize to protect human health and welfare. States and tribal lands are required to attain and maintain these standards in all its counties, or EPA designates the region as being in non-attainment. For the work, we use the data from the EPA air quality system, hourly files of ozone and NO2. Along with this, we also use the USU measurements of ozone and NO2. Days with at least 75% of the hourly data have been used to calculate the monthly mean. We use the well drilling and completion and oil and gas production data from the Utah Division of Oil, Gas, and Mining. And we made use of the smoke days from the NOAA hazard mapping system, fire and smoke product. With that, I will move, and also the data period is between 2010 and 2020. With that, I'll move to the results of the study. The top right figure shows the site names from where we have the measurements of ozone and NO2. Not all the sites measure ozone and NO2, might not be going into it. And there are a couple of sites like Castle Peak, Horsespool that operate only during the winter time. For calculating the trends, sites with 5 or more years of data have been used to do the trend calculation. We've used both the parametric and non-parametric method. For the rest of the presentation, parametric method following Weatherhead et al. 1998 paper has been used, and both the methods have been comparable. We did actually a calculation of the annual and the monthly trend to look at both the local as well as the long-range transport effects on ozone and NO2 in the Uintah Basin. So the figure on the left shows the trend in ozone and NO2 in the Uintah Basin for the winter and spring seasons. Overall, a decreasing trend at most of the sites, but I would like to point out Castle Peak, that is on the western Uintah Basin in the magenta color. It shows an increasing trend in ozone, and it is related to the increased oil and natural gas activities, which I'll be talking about in my further slides. And there is an increase in NO2 at Vernal. This is because of anthropogenic activities other than oil and gas. There is a significant decrease at Ouray, Redwash, and Horsespool. These 3 sites are in, do you have a laser pointer on this? Oh yeah, it's in the central UB. I'll be referring to that a couple of times in my presentation, where you see a significant decrease in ozone. We also looked at ozone and NO2. We also looked at the trend in ozone and NO2 during the summer and fall seasons. Of course, it's opposite to what we see during the winter. There is an increasing trend in both of it, and it's mostly at the sites in the northern rim of the Uintah Basin, and this is because of the effect of smoke from wildfires. Again, there is a decreasing trend in central UP. The takeaway point from both these slides is there's a statistically significant decreasing trend in both ozone and NO2 in central UP in all the seasons. And these are the sites which are near to the oil and gas activities, which indicates that there is a decrease in the emissions from the oil and gas sector. The changes in NO2 were further substantiated making use of the satellite observed tropospheric column NO2. So the tropospheric column NO2 from ozone monitoring instrument on board Aura satellite has been used. It has an equator crossing time at in the afternoon around 1:30, and it gives spatial footprint at 13 by 24 kilometer. So the tropospheric column NO2, and in each pixel, it has been graded to 0.25 to look at the variation in the Uintah Basin. So why tropospheric column NO2? It can be used as a proxy for NOx emissions because of 2 reasons. First of all, the NOx has a short lifetime. So whatever enhancement that is seen in the column NO2 could be attributed to the local emissions. And secondly, most of the NOx exists as NO2 because NO gets rapidly converted into NO2. And the trends were calculated in each grid, and the trends is shown in the top right figure, and the statistically significant trend is shown by the white cross, and the blue square shows the location of the ground-based monitoring station. So as observed in the ground-based observation, statistically significant decreasing trend in central UB. Of course, there are a few grids, they show lower degrees. We also made a comparison of the ground-based monitoring observations with the satellite measurements at the satellite overpass time, and the monthly changes is shown in the lower right figure. So both the data sets show a similar pattern with high values in the wintertime attributed to the low ventilation coefficient, and lower values in summer. It could be attributed to the vertical mixing, the advection, and also the lower lifetime of NO2. And of course, both the data sets also show a decreasing trend. So the trend in NO2 was further looked in association with the oil and natural gas activities. So that is the oil and gas production, as well as the NOx emissions from well drilling and completion. So we looked at the trend at two regions in the Uintah Basin, one in the Central Basin, so we took red wash, and the other in Western Uintah Basin, so we took Miton. And these are the sites where we have measurements of ozone and the ground-based measurements of ozone and NO2. The top left figure, it shows the number of oil and gas wells. It is gridded at 5-kilometer resolution for the period 2018 and 19. Note that Central UB is dominated by gas wells and Western UB by the oil wells. The bottom figure on the left, yeah, there are a lot of things happening in that figure, so I'll just go through it. The red line, it shows the monthly variation in the tropospheric column NO2. The blue line in figure A, it shows the monthly variation in the total gas production. The dashed blue line in figure B shows the oil production, and the solid black line, it is the calculated NOx emissions from well drilling and completion. I won't be going into the details of that. It was a work actually done to look at the impact of electrification of oil and gas fields on the air quality in the Uintah Basin, and the report is available on the Bingham Research Center site. So anybody who wants to know more details about it could read it. So what we see is the decrease in NO2 column in Uintah Basin at red wash. It is associated with the decreased gas production by more than 50% over the years. And on the other hand, what's happening over Western UB is there is an increase in column NO2, and it is associated with an increase in oil production, and it has increased by more than 250% since 2017. And another thing what we notice is that column NO2 were high at both of these sites, in both of these grids, even before the oil and gas production increased, and that is associated with the increased NOx emissions from the well drilling and completion. And therefore, we see that we can conclude saying that the decreased NOx emissions associated with the oil and natural gas activities is the primary cause for the significant decrease in ozone in Central Uintah Basin. And if you have to think about it, if emissions from Uintah Basin influenced ozone within the Uintah Basin, we would expect that there should be a significant decrease in ozone at all the sites in other seasons. But we see that there is an increasing trend during the summer and winter, which is associated that there are other factors contributing to ozone production in Uintah Basin. So we looked at the smoke from HMS, and the figure on the right, it shows the variation in the number of smoke days in Uintah Basin, along with the variation of ozone at sites in the northern rim of Uintah Basin. So I included the sites DNMUT, Little Mountain, Vernal, and Roosevelt. So what we see is interannual variability in ozone is controlled by the interannual variation in smoke days. And if you have to look at the correlation, a higher correlation is seen in the summer seasons than in the fall. Enhanced ozone at sites in the northern rim, it's because the smoke plumes, they interact with the urban air mass, and it can lead to ozone production. And secondly, the dilution of smoke plumes with the cleaner background air in Central Basin and in eastern Uintah Basin, it leads to less to no effect at sites in both of these regions. And in recent summer, there has been an ozone exceedances due to wildfires. And with that, the concluding thoughts: increased drilling and oil production in Western UB has increased NO2 and ozone. If controls are not taken, ozone exceedances are expected in the coming winters. Decreased well drilling and gas production is a primary cause for the decreased NO2 and ozone exceedances in Central Basin. Future studies should investigate the impact of local emissions on the ability of wildfire smoke to produce ozone. Summer ozone exceedances would impact the attainment of ozone standard in the future, if not for the exceptional events. It removes the threat of non-attainment for the national ambient air quality standards by neither reducing the smoke from wildfires or its health impact. Thank you. And with that, I'll take the questions.
Okay, who has questions for Liji and is brave? So I think, oh, go ahead.
So you were looking at the ozone trends from, or the NO2 trends from OMI. Did you look at any places outside of the Uintah Basin? Because it would be really interesting to look at what those trends are outside the basin that in theory wouldn't be affected by the oil and gas drilling, and see, what the, kind of broader region trends are in the OMI data. Have you looked at that?
That's a good question. Little Mountain site is right at the edge of Uintah Basin. And that's one of the sites we don't see an impact of oil and gas activity. Of course not. And so the edge of Uintah Basin, that's outside of the Uintah Basin, would be mostly influenced by what's happening outside of the region. Yeah.
We've got time for another. The 3 bells means we have a minute or two.
So how does, I'm unfamiliar with typical NO2 concentrations in, like, let's say an urban area, but one thing that's been cited is you often need NO2 or NOx to get ozone to form within smoke plumes. And when those smoke plumes are outside of urban centers, you don't get as much ozone production. So how does, like, the NOx concentrations that you see within the Uintah Basin during the summertime compared to that of, like, urban centers?
No, can you repeat your question, please?
So how does NOx concentrations during the summer compared to, like, in the Uintah Basin compared to, like, urban centers like the Salt Lake Valley?
Oh, that's a good question. I haven't even looked at the NOx values compared to Salt Lake City during the wildfire, but I think it's comparable throughout the season for us. But we need to look at how the smoke from wildfires is gonna enable the formation of ozone. That's something that we need to explore, and even I haven't looked into it.
Yeah, we got time for one more quick one.
Showing increases in nitrogen oxide emissions corresponding with ozone increases as well in the North Rim. Is it possible that the added NOx concentrations are contributing to local photochemistry outside of the impacts of the wildfires?
Can you repeat that question? Sorry, I have to ask.
No, that's fine. So we're seeing increases in NOx concentrations as well in the north, right? And a corresponding increase in ozone during summer.
Yes.
So is it possible we're seeing some local photochemistry associated with the added NOx emissions?
Oh, that's actually during the smoke wildfires, there are multiple ways how ozone can be formed. So there are studies that says that if it mixes with the open air mass, it can lead to ozone formation. There are also studies which says that it can lead to ozone destruction. So we don't know exactly what's happening in the northern rim, especially like those are the locations like Roosevelt, Vernal are the locations where Uintah Basin has the maximum population. So we assume that that's when, like, it's mixing with the urban air mass and leading to ozone formations. And that's how we have observed the exceedances happening in the recent summer. Yeah. So wait for those studies. I think it should be coming up in 1 or 2 years. Yeah, we'll have those results out.
Great,
yeah.
Thank you.